Hi, in this video, I answer the question of when is it that this is equal to that? We know that we're not supposed to do it, right? When you have this, which is the derivative of a product, you're supposed to use the product rule. You're not supposed to just multiply the two derivatives like this, no. But hey, even a broken clock is right twice a day. When is it that you do something like this and you look out and it's coincidentally true? I'll answer that. All right, we're going to find u and v, functions of x, such that the derivative of uv is actually equal to u prime v prime. We know it's not supposed to be. It's supposed to be u prime v plus u v prime. Well, we're going to solve for instances where it's coincidentally equal to u prime v prime. So we have an equation in two unknown functions u and v, and they're symmetric. You switch places of u and v, and it's the same equation. So we're going to concentrate on one of them. It doesn't matter which one. I choose to concentrate on u. So I'm going to combine all the u prime together and all the u together. There are two u prime terms, so I'm going to put them together. I have u prime times v minus v prime. And then I have the u term plus u v prime is equal to 0. So far, all I've done is algebra. And I want to isolate the u prime, so I'm going to divide both sides by v minus v prime. I have u prime plus u times v prime divided by v minus v prime equals 0. This is an equation where the unknown is not just a variable, but a function. And that function came with its derivative, i.e. its differential. And therefore, this is a differential equation. We call this a first-order linear equation. And there's a standard way of solving this. It has to do with noticing that this looks almost like a product rule. If you have uw prime equals 0, then you'd have u prime w plus uw prime equals 0. Look, we have the u prime and the u, and something that may be w prime, maybe. Well, that can't be, because if this were w prime, then this factor of 1 here would have to be w, and the derivative of 1 is not that complicated thing. So maybe not quite, but we're thinking maybe there was a factor of I that is in both w and w prime, and then it got factored out and canceled. And that's why we have this right now. So what about if we put it back in? That is called an integrating factor. It's a standard procedure in solving differential equations of this kind. I have already made a video about it, so check it out above. But what it consists of is to find that integrating factor I and multiplying both sides. And the formula for I is standard. I'm going to let I is equal to e to the power of the integral of this. So e to the power of the integral of v prime over v minus v prime dx. And let's see what happens. The derivative of I will be, well, derivative of e to the power is e to the power. So first is e to the same thing again. But by the chain rule, is times the derivative of the exponents. So times the derivative of the integral of v prime over v minus v prime. Well, what about it? This part, you have an integral and you have a derivative, so they cancel each other out. All of this is just v prime over v minus v prime. E to the integral of. And all of this is the derivative of I. Okay, so I'm hold on to this. I'll go back to this equation. Let me erase the part over here. I'll call this equation star. I'm gonna multiply both sides of star by I. Star was u prime plus u times equals 0. I multiply both sides by I. I have u prime of I times u of I times that, right? And I is that exponential, so I plug it in. Well, check this out. This is I, and all of this is I prime. So I have my product rule. I have u prime I plus ui prime is equal to 0. This is a product rule that says it's the derivative of u times I. So now I can just integrate both sides with respect to x. On the right-hand side, I have a constant c. And on the left-hand side, the integral and the derivative cancel. I have u times I. And therefore, u is equal to c over I, which is c over e to the integral of v prime over v minus v prime dx. I'm going to bring the exponential from the denominator to the numerator by using negative power. And the last thing I do is I'm going to bring the negative sign inside the integral. And I have my function u. You may say, well, wait. So what is it? What is u a function of, right? You're expecting something like u is equal to sine x and v is equal to cosine x or something along that line. And you don't see anything like that. Well, yeah, you don't see that, but this is actually better because it means you can pick any v and you go through this calculation, then you will get a u that goes together with it. That means there are infinitely many solutions to the possibilities of uv prime equals u prime v prime. What it means is you pick any v that's a function of x, any constant c, and then you can get u, and then for that combination of u and v, you will have uv prime is equal to u prime v prime like that. Infinitely many solutions. So let's do an example. You can pick any v. If you pick v is something complicated like sine squared of x, then the integral may not be doable, yeah? But it's still a legitimately defined function. It is perfectly legit to define a function in terms of an integral of something. There's nothing wrong with that. But if you want something that is nice, then we want to keep v as something nice. So I'm thinking exponential, for example, would be nice because v prime and v are the same form. So when you do v prime minus v is something nice. I'm thinking single power of x, then the v prime and the v prime minus x may cancel out. Like, there are things like that. So let's do an example. Let's set v is equal to exponential, but I don't want to just do e to the x. You know why? Because then v prime minus v is just equal to 0, and I'm going to be dividing by 0, and that's bad. So I'm going to make it off a little bit, e to the 2x. Then v prime is 2e to the 2x. V prime minus v is equal to 2e to 2x minus e to the 2x is equal to a single e to the 2x. V prime over v prime minus v. is just 2. So the integral is just integral of 2 dx. Is equal to 2x. We could do a plus c, but it's not necessary because it would just be subsumed by that c in front. So u is equal to c e to the 2x. And we can pick any c. So let's say 5. Then I have u is equal to 5e to the 2x and v is equal to e to the 2x. Let's check. E to the 2x times e to the 2x is e to the 4x. And that is equal to 20 times e to the 4x. U prime is 10e to the 2x. V prime is 2e to the 2x. Which is equal to 20 times e to the 4x. Yep, it works. Another example, let's say that I want to use power. I want v to be a power of x. Let's say x to the 4th. Then v prime is 4x cubed. And v prime minus v is, and v prime over v prime minus v is equal to 4x cubed divided by 4x cubed minus x fourth. I can factor out an x cubed in the denominator. And these cancel and I have just 4 over 4 minus x. Now I integrate both sides. And this one is 4 negative 4 ln 4 minus x. If I do a quick u substitution where u is equal to 4 minus x, du is minus dx, etc., then I have negative 4 ln of 4 minus x. And my u is supposed to be some c times e to the power of this integral. And the integral is all of this. And I want to put the ln and the e together. So I'm going to use property of logarithm and put the negative 4 power in there. Negative power means 1 over. And they have 4 minus x to power 4th. Absolute value to power 4th. But power 4th is always positive. So I don't need the absolute value anymore. I just regular to power 4th. And now the e to the power and the ln cancel. These two cancel. And I have my u as c times 1 over 4 minus x to the 4th. And let's say that I use c equals 1 to make it simple. Then u is equal to 4 minus x to negative 4. My solution is u Now let's check it out. uv is equal to 4 minus x to negative 4 times x to the 4th. uv prime is equal to negative 4 minus x to negative 5th times negative 1. So all of this is derivative of u times x to the 4th plus 4 minus x to negative 4 times 4x cubed. Let's simplify this. Negative 4 times negative 1 is a positive. And I can factor out a 4 minus x to negative 5 on both factors. So from the first term, I have x to the 4th left. On the second term, I have a 4 that comes out. I have this one comes out, so a regular 4 minus x is left. Okay, you can double check. This to power -5 times this to power 1 is the same as power -4 and x cubed. Most of you probably are not familiar with factoring out a negative power, so you may want to like multiply it back in to make sure that I factor correctly. Times. Now let's simplify this. X fourth plus 4x cubed minus x fourth. Oh, look, these cancel. 16. All of this is uv prime. U prime by itself is -4, 4 minus x, -5 times -1, which is 4 times 4 minus x to -5. V prime by itself is 4x cubed. Oh, look, yeah, if I do multiply them together, then yep, I definitely get uv prime. Well, there we go. Pick any function v and any constant c, plug it into this formula, then you can compute a function u. Then the u and the v that you pick here will go together to satisfy this derivative uv prime is equal to u prime v prime. All right? Hope you had fun. Any questions, ask in the comments and I'll answer. Share, like, and comment for more contents. And thanks for watching. Bye.